Welcome, everyone. For those who don't know me, I'm Shah, and this is the Data Entrepreneurs. We are a community of entrepreneurs focused on pursuing ventures that have data and AI at their core. Data-focused and AI-focused businesses and other types of ventures, which is why I'm super excited about today's workshop, where Shiv is going to be talking about a major pain point in AI these days, which is evaluating this incredible new technology of large language models. So Shiv and his co-founder Himanshu have been building Athina.ai, and the past several months they've been really going deep into this, I don't even know what to call it, but this rabbit hole, or maybe it's something else, of LLM evaluation. So with that, Shiv, just going to hand it over to you so we can all start learning.
Well, thank you so much, Shaw. Definitely a rabbit hole. That's what I would call it too. So thanks everyone for joining. What we're going to discuss today is how you can use LLMs as effective evaluators, right? So I'm going to get started by going over, what are evaluators, why do you need them, and then we'll actually just try to build some simple evaluators, using prompting, and then we'll take it up a notch and try to build, use more advanced techniques and build better evaluators. And then I'll share some best practices after that. So let's get started. So just a quick background about myself and my team. We've spent most of the last year building a platform specifically designed around LLM evaluations. We realized this is a problem when we spoke to, pretty much everyone building any kind of product using AI. Has discovered that it's really hard to figure out when it's saying the right thing and the wrong thing. And seems to be a universal problem, especially with generative AI. So in the last, several months, we've built over 40 different preset evaluators. We've also integrated with, top state-of-the-art libraries like Ragas. And at this point, we're processing millions of requests every week, running hundreds of thousands of evaluations. So we've picked up a few things along the way, and that's what we're going to be talking about today. So like I mentioned, agenda, we're just going to start why you need them, different types, and then we'll just get into the practical stuff of building an evaluator. So let's get started by why do you need evals, right? So most people who start out on their journey building any kind of LLM-based product start out by just, evaluating by eyeballing the responses. And at that point, you're kind of in this mode of, well, I guess it kind of works sometimes, right? Like you just know that sometimes it works. And at this point, everything is a challenge. Your whole life sucks. There's nothing good. Level 2, you get into like, running it in batches and putting it onto a spreadsheet. And at that point, you're basically doing the same thing, but you're just eyeballing 10 responses at a time or maybe more. It still takes a lot of time, and it's not automated. You don't have a good measurement system or a way to track things, but at least you can look at 10 things at once instead of one thing. So it's still a lot better than just eyeballing one at a time. Next step is, get into this territory where you have what people call a golden data set. That's basically a data set where you know what the output should have been. So if you know what the output should have been, and you also know what your output was, you can compare the two in some kind of automatic way using an evaluation. And that's actually a pretty good place to be. Like if you're at this point, you're probably not doing too bad. But you will have challenges like, you can't run this unless you have a pretty good data set like that. You can't track experiment results very well. The data set might not represent production, and it's still kind of a pain because you're still, operating with spreadsheets and obscure numbers. And then level 4 is automatic evaluations, which you can run with or without a golden data set. You can run these in development, CI/CD, production. All of them will have metrics for which you can use to compare the performance of different models, different prompts, different retrievals. And this is where really you start to see, just 10x faster iteration cycles, because at this point you can just run the evaluations and let the evaluation tell you which model is better or which prompt is better, rather than you trying to eyeball things or do it manually. And you can even get really granular, like, you can answer questions like, how is my customer support V1 prompt performing on the Gemini model for queries related to refunds? And that's really like a place where, all your evaluation needs are covered and you're doing pretty well. At this point, your only challenge is that your sales team sucks and they can't sell it fast enough. Quick plug, Athena can help you get straight to level 4. So skip all of this stuff. So just a few notes on like the different types of evaluations. You can have human review, which is, eyeballing, good starting point. User feedback is actually the best signal for, it's the signal that most closely tracks how well your product is performing for your business case. The problem with user feedback, by the way, is like thumbs up, thumbs down stuff. The problem with that is people don't click those except when the response is very bad, typically. So you'll have sparse data sets and limited information. Now you can have implicit user feedback, which is basically, how does the user interact with the product after your LLM part? So let's say you're generating an email and you generate 100 words, and then the person edits 20 of those words. That gives you some signal, and that it's worse than if the person edits 0 words, right? So that can be useful, but it's tricky to bake these in, and they're not, and you'll still, most of the time, you won't be able to bake in enough of these to have enough of an evaluation, enough eval information. So still pretty good, but not all that you need. Comparing against a reference is the golden data set that we talked about. And then ungrounded evals is, a lot of what we'll focus on in today's talk, which is how can you actually run evaluations in production when you don't have a data set or when you don't have reference responses in your data set. So we'll be focusing on the last 2 sections, but in general, it's a good practice for you to have all 4 of these in some form or the other. So let's start with evaluation when you do have label data. So that would be the 3rd column over here. So when you do have labeled data, this is what your data set might look like, or this is what what a data point might look like for you. So let's just say that you have a query, which is who founded YC? And the response that the LLM gave out was YC was founded by Paul Graham in 2005. But the expected response you wanted was this, which mentions 4 names, not just 1. And a few other examples that I have here are like these. So all of these are cases where your LLM gave you, either it's something completely incorrect, or it's something which is, missing some information, or maybe the LLM just straight up, said, I just don't know. In these cases, it's still pretty tricky to evaluate without an LLM. There are algorithms and matching techniques that you can use, but I'm not really going to go into most of those right now. If those can work for your use case, that's probably the best thing to use. But most of the time, your responses are going to be too complicated for that. So for something like this, you can use a pretty simple LLM prompt to evaluate this. And the prompt would just look something like this, this is my response, this is my expected response, determine whether all the information in the response is the same as the information in the expected response. And you can constrain your LLM to return a pass-fail along with an explanation. So that way you get a consistent output. So this is actually pretty good. You're going to be able to catch things like this. I plugged this exact prompt into ChatGPT, ran this evaluation, and it came up with this reason that the given response does not include all the co-founders. It only mentions Paul Graham, while the expected response includes these, right? So the nice part about using an LLM is that you also get an explanation. If you ask it, you can also get an explanation for why the evaluation passed or failed. This is just an introduction into how you can use an LLM as an evaluator. After this, we're going to go a little bit deeper into other techniques, and most of those are going to be when you don't have a reference response or an expected response. But before that, I'm just going to answer a few quick questions which come up when anytime we discuss LLMs as evaluators. It is a meta concept, so I'm just going to address a few questions right out of the bat. First of all, why do LLMs make good evaluators? They're the best tool that we have to deal with unstructured text, right? We don't have anything better today. Um, and they are very flexible, so you can use them for all kinds of evaluations. It's not constrained to a specific type of evaluation. You can use them for for comparisons, coherence, safety, conversations. There's a whole host of things. If you can imagine it, you can probably use an LLM for it somehow. And then finally, they can perform complex reasoning tasks, and your only alternative to an LLM there would be to use, to have a human in the loop, which is unscalable. So that's why. Now they are not perfect by any means. You'll never get an LLM evaluator that's going to be 100% perfect, but if you can get it to be really powerful and really quite accurate, and we'll show you how you can do that. So just a quick, question which comes up a lot is, why would the LLM evaluation work if the LLM failed to do the inference correctly, right? Like if I use GPT 3.5 for my inference and I use GPT 3.5 for my LLM evaluation, why would the evaluation work? So the reason is that you're fundamentally you're doing two different tasks, right? So imagine that I gave you two tasks, and one of the tasks was draw a circle. And the other was, is this a circle? Most people can identify that something is a circle pretty easily, but it's very hard to draw a circle accurately. And that's kind of the analogy that I would give you here, which is that your main inference task is probably doing something more complex, but your evaluation is supposed to break that complex thing down to just measure something pretty simple. And just identify that how well did it do that specific thing. So that brings me to the most important tip about creating any LLM evaluator, which is keep it stupid simple. The simpler the task, the less likely the evaluator is to mess up, and you don't want a flaky or unreliable evaluator. So try to keep it as simple as you want. Don't make it ambiguous. Like break the task down into smaller steps if you can, and that will give it less chances to screw up. So yeah, so just going back to that simple example of the response versus expected response, you can see here that I never gave it the user query. I never told it what the question was in this prompt. I never told it any other information other than these two things. So I'm trying to, this probably still could be simplified even more, but basically this is a pretty simple task, right? If you're asking the LLM like, hey, compare these two things, tell me what the difference is, that's relatively simple for an LLM to do. And if you want to break it down even more, you can break it down by sentence, or there are some other ways which we'll get into. So now let's try to create an evaluation without label data. So let's say we don't have the reference response. What can we do then? So in this case, I have a simple chatbot that I've built, it's a RAG chatbot. It's basically the simplest RAG architecture that you can imagine, which is that a user query comes in, I do some sort of retrieval from my vector database, I create a prompt, and then I generate a response from my LLM. Most RAG architecture looks something like this, but you'll often have, it can get a lot more complicated than this as well. Now, my embeddings were generated from the Y Combinator FAQ page. So I am trying to answer questions like this. How much does YC invest in each startup? Who founded YC? Does YC invest in international startups? Things like that. Now, all of these answers are actually wrong. But how would you know that if you don't have a reference response? So that's what we're trying to get at, is how can you evaluate these? And one technique that you can use is that you can use your retrieved context as the ground truth data. So just because you don't have an expected response doesn't mean you don't have the answer somewhere. If your retrieval step was good, then the retrieved context is a perfect thing to compare against. And this is what we would call a faithfulness evaluator. Faithfulness or groundedness is what we've been calling it. And basically what this does is it's comparing your LLM response to your retrieved context in a similar manner to what I showed you with the response and expected response. So and the prompt for this might look something like this, where you're saying, consider the following context and response. Note that I'm not providing it my user query or prompt or any other information here. So it doesn't even know what the question was that the response is trying to answer. All it knows is the response and the context. And then what I'm telling it is determine if this response can be inferred using only the information provided in the context. And then this is all just like trying to get it to respond with a JSON object and give it some examples. And this works pretty well. Like you will find that it will return, if this is the example, user query is what is Y Combinator. This is the retrieved context, let's say from Wikipedia. And then the response has all of these three sentences. Now you'll notice that this sentence isn't actually in the context, which would make it an unfaithful response. Unfaithful responses are a pretty good indicator of hallucinations. They are not always hallucinations. So in this case, this information is actually true. It's probably coming from the LLM's pre-trained knowledge. But typically when, in most RAG systems, you don't really want the LLM to deviate too much from from the context that you've provided it. Because, and if it does, then that's a signal of a hallucination. It's not a guarantee of a hallucination, but it indicates a hallucination. So you can see that this evaluation will fail, and it'll come up with a pretty good reason that this response includes information about these companies that cannot be inferred from the provided context, as these companies are not mentioned in the context, right? So your evaluation is basically just only looking at this and checking if there's anything here which isn't backed up by this. So yeah, this is pretty good. But one thing that some of you might have picked up on is that it will depend on what your data looks like. If your data is very large, your context is very large, your responses are large, or even and sometimes pass fail is just not granular enough, it doesn't actually quantify the evaluation very well. It just, it gives you a pass or fail. But the problem with pass or fail is that it's binary, and in ambiguous situations, it can be a little nitpicky. It's also, it also doesn't give you a great way to compare, results. Two things can be passed, but one can still be better than the other or more faithful than the other. So let's look at how we can improve this and get to version 2. And this is actually going to be more reliable and more, this is going to be more reliable and more, more granular. So it's going to come up with a score. So what we're doing in this one is we're actually, the two new ideas that we have here are, we'll break it down sentence by sentence, and then we'll check what % of sentences were actually faithful. So if you have, and this is the prompt for that, but I'm going to just skip that. So just in the same example, you know that one out of these three sentences was unfaithful. And so that'll give us a faithfulness score of 0.67 because we had two faithful sentences and one unfaithful sentence. So that tells us that, okay, this is a, 0.67. And you can see that this could work really well if, let's say, you're doing, like, for example, some of the people we work with, they're like meeting note taker apps. And so you're summarizing a meeting, you have a summary of a meeting, and you're trying to detect how many of the statements in that summary are not faithful to the original source. That can give you a sense of, it can give you a way to quantify that if you break it down sentence by sentence. And the other thing that's great about breaking it down is that it also makes the task simpler for the LLM, because now all the LLM has to do when it's thinking about this and reasoning is this sentence present in this context, right? It's looking at it one sentence at a time. So that makes the task a lot simpler, and you can even do it more effectively with a cheaper model. So what we have found is GPT 3.5 will perform really well with this, but with the original prompt that I showed you, GPT 4 would do a lot better than 3.5, whereas in this, GPT 4 will only do marginally better. Now, if you're, another thing that you might have noticed here is, like, I'm going pretty deep on this faithfulness evaluator, but very often the problem is actually one step before. It's in your context, it's in your retrieval step, right? And so that faithfulness evaluator relies on us. It assumes that your context was good, but that's not necessarily true. And so a really important thing when you're setting up an evaluation pipeline for yourself is that you want to evaluate your entire LLM inference pipeline including, and probably most importantly, the retrieval step, right? And so the way you can evaluate that is to compare the user query and the context. So a very simple idea for that would just be, hey, does this context contain all the information I need to answer this question? If it doesn't, then you've now identified that this context is just like, the problem is that you have a bad retrieval. It's not that you have a bad prompt or a bad generation. It's even before you got to the prompt, you had a problem in your pipeline. So that can help you, score your pipeline at different stages of to see where things are going wrong. Now you can break that down as well into um, these different tasks. So for example, for context relevancy, you can check. Typically your retrieval will fetch multiple different chunks. So maybe you fetch 3 chunks, and you can score the relevancy of each of those separately. One other thing that you can do, it doesn't work for all situations, but you can do this as it can work in if the task is simple enough, is that you can actually ask the LLM to give it a score, right? As long as you define, like what I found works best is give it a scale of a very defined scale, like 0 to 5, and explain what each of those means. 0 is not at all relevant, 5 is completely relevant, and then you can explain that 1 is when it's not really relevant but maybe contains some tangential information, and 4 might be it's mostly relevant but it contains a lot of extraneous information. So if you can define your scoring rubric or criteria over here, LLMs will actually do a reasonably good job at scoring it well. Right now, there are nuances, like it might, put something where you thought it should be a 3, it might give it a 4, but on a relative basis, it's pretty good. And so what that lets you do is you can do these techniques like you can score each of your context chunks individually. So you can say, like, tell me the relevancy of this context chunk to this user query, and then tell me the relevancy of this chunk and this chunk. And now you have 3 different relevancy scores. So first of all, you know which chunk was the best retrieval. And secondly, you also know that on average, how good is your retrieval if you average these numbers out. Now, there's a lot more you can do here, but I'm not going too deep. I want to just like show you some of the different techniques, and then you can kind of apply these to your own system in the way that makes the most sense. Just keep in mind that relevancy is a criteria that I've picked. You could pick something completely different, right? Like you could pick whether it contains specific attributes that you care about or something else. For summaries, there's another technique which is actually it's a little bit more complicated, but I'm going to give it a shot to just explain it here. So the technique is that you generate a bunch of questions from your. So by the way, the summary use case that I'm talking about is you have a source document that an LLM is summarizing, and you want to evaluate if there are any hallucinations in the summary. So the technique that we have here is take the summary, the generated summary, use an LLM to generate 10 closed-ended questions from it, like yes/no style questions. Then ask an LLM to answer each of those questions using only the summary as a context and using only the document as a context. And then now what you have after doing that is you have 2 sets or 2 pairs of question answer sets, and your score is going to be the agreement or contradiction between those 2 sets. So I'll give you an example so it'll make it a lot simpler. So let's say I generated a summary, it had all this information. I now generate 5 questions from that summary. So I generated these 5 questions. These are all yes/no style questions. I then asked an LLM to answer each of these questions given only the source document. And then I asked an LLM to answer each of these questions using only the summary document. You'll notice that 3 out of 5 of these questions had a perfect match, as in the summary and the source agreed. But in 2 out of 5 of them, the summary and the source disagreed. So those would be examples of hallucinations or contradictions, where if the LLM says the summary says something that the source did not know about, that's a pretty good indicator of a hallucination. So there's a blog post about this, and I will make sure that there's a link somewhere you guys can access for this. We've written a blog post about how you can implement something like this, and we also have a library of these evaluators. So yeah, I don't have a lot more time. So, but I just wanted to give everyone a quick introduction to the different types of techniques that you can use for evaluation using LLMs. You can also do similar things for evaluating conversations, prompt chains, retrieval systems, checking for bias and safety, PII, prompt injection, a lot of different things. Most important thing is to just break your task down into something that's pretty easily identifiable, right? Like always go back to that, is this a circle versus draw a circle example? And I think that will get you pretty far. And a few other pro tips are, if you're running these in production, create a rubric of evals. Don't expect one eval to solve all your problems. Make sure that they actually track your business success case well. Set a sampling percentage. You don't want to be running you don't need to run evaluations on every single log in production. You only need to run it on a good enough sample size so that you can get performance metrics. Make sure the results are normalized, JSON or something like that. Use chain of thought prompting, and try to segment your evaluation sets by what prompt, by your prompt, your model, whatever criteria you're trying to optimize for. So if you segment them by model, then you can actually see, okay, my evaluation gives me a score of 0.85 with GPT-4 and 0.83 with Gemini, so I know that GPT-4 is better. That's really the goal, is to come up with some way that you can compare these. And finally, I will plug Athena, which is what we've been working on. So we have an open source SDK that you can use with all of these evaluators. We've got I think almost 40 evaluators. We're adding more every week, and we also have a platform that ties into. So I'll just show you what that looks like. It's a full monitoring platform where we run all these evaluations. You can plug and play, configure any of the evaluations that I've talked about, just like this. They'll all run, and you'll be able to see the results over here in the sidebar, along with the reason for the evaluation. And all of these will also roll up into some performance metrics. So you can use these to understand how your model is performing in production. And you can also use these to compare different prompts and different models. So if I want to see how different prompts are doing, I can quickly come here and I can see that, okay, this prompt is performing the best on all of these criteria. And I can do the same for language models or topics or other things. So I can come in here and I can see that GPT-4 seems to have the highest faithfulness score out of all the models that I've tested. So that's a little bit about about Athena and how we are doing all of this. But you can also just feel free to use our open source SDK, and you can also feel free to just try building these evaluators yourself. If you have very custom things that you want to do, we do support custom evaluators, by the way, but if you have very custom things, you can also, it's worth a shot to just try building them yourself. And yeah, thank you very much. I think I'm at time, so thank you very much for your time. I appreciate it.
Let's all give Shiv a round of applause for a awesome workshop. I feel like this was like as good of a primer as anyone could ask for on LLM evals. I got a ton of notes here, and I feel like I'm all caught up and ready to start evaluating LLMs. Let's open it up for Q&A. So if you guys have questions, drop it in the chat, raise your hand, and then Shiv will answer your question. Yeah, Santiago, go ahead.
Hey, Shiv, I just had a question. This is all very relevant to a project I'm working on. My project also has an element of speech to text, which we're using Whisper and we're trying to evaluate things. And I'm just wondering if you had any thoughts on that, because we're going from speech to text, and then we're trying to extract insights from the text. We actually run the speech, the transcribed speech through GPT to do some corrections, which sometimes it does great, other times it just goes off the rails. But sort of our ground truth is still, barring actually hand labeling transcriptions, our ground truth really is audio. I don't know. I'm just wondering if you had any thoughts on how you might tackle, or apply this concept of evaluators in a scenario where you're starting from speech, and transcribing and then extracting insights from.
Yeah, thanks, Santiago. That's a really interesting one, and we do work with some people for that. I don't have any immediate insights into how you can evaluate the speech part. What I would do is I would definitely make sure that you're evaluating the rest of the pipeline separately so that you know that as long as you're getting a good transcription, you should be able to know where the leaks or the flaws are beyond that point. But one of the biggest challenges for any voice AI type of product is going to be how good can you get that transcription to be. And unfortunately, I don't know of any great ways to evaluate that. But I would love to hear some if you figure anything out. I do think probably like some kind of evaluation with the reference response, like where you have a golden data set or something like that is going to be best. But ultimately, if you're still relying on the if you are relying on the base model like Whisper or something for the transcription, then I'm not really sure how much power you're going to have in making that better. Although that idea of using GPT to improve it is pretty interesting. I'd love to know how well that's working.
Yeah, thanks, Shiv. Yeah, in general, just a quick to comment on that. Like I said, I think it works fairly well. I would say and again, I'm in the eyeball stage, in terms of valuation. So I'm eyeballing things, but I would say, about 75% of the time it does a pretty good job correcting things. We give it some simple prompting with some domain specific words that are likely to be encountered, and it does pretty well. It starts to go off the rails when more static comes into. These are like radio broadcasts, so when more static gets into the picture, then it starts getting dicier. And unfortunately, we don't have a way to really tell, or we haven't developed a way to tell how distorted is this source broadcast. So
do you have like a golden data set, or do you have a data set with the correct transcriptions?
We are in the process of figuring out a way to start building one, but we don't have it yet. I'm sure once we have that, then that'll open up a lot of opportunities.
That's where I would start for sure. Like if you have 100, even just 100 rows like that, it's going to make it infinitely easier for you to try out new models and just see how you can improve that transcription piece. Or yeah.
Agreed. Awesome. Thank you, Shiv. Appreciate it.
Yeah,
I'll just throw in one other thing, Santiago. If the static is causing issues, that's a pretty solved problem of extracting voice from audio. So maybe a pre-processing step could help you guys get along a little better.
Yeah, I appreciate that. We've actually looked at that, and here's an interesting thing we found. Again, eyeballing. The Whisper, we're using Whisper. It does actually pretty well, even when there is a moderate amount of static. Like it is able to do pretty well in cases where it takes me kind of a while. It takes me a few tries to figure out what it is. So there is this threshold where it's actually performing.
That's cool.
Performing really well. But yeah, we've yet to try. I know there's noise reduced type of stuff that I should try out as well. Thanks.
Yeah, that's awesome. Thanks for the question, Santiago. Anyone else? Feel free to drop it in the chat or just go ahead and raise your hand. We've got a fair amount of time for Q&A. So I guess I got a question, Shiv. I'm curious because if these, let's say you're using GPT 3.5 or GPT-4, you got to think about the API calls, you got to think about latency, you got to think about API costs. And now and that's just for your app and your business case. Now you're adding this other evaluator on top. So is this something that, you're seeing offline or online applications? Is it for both? And how do you kind of balance all those costs?
Yeah, so I would definitely view these as I would not try to use these in real time, in your application, mainly because of the latency issue. There are probably some applications where you can be okay with that, but most of the people that we work with or that we see, any chat app, any voice kind of application, any code generation or anything like that, latency is going to be a big concern. So I would not try to use these in real time. I would definitely try to use these as an analysis tool and a development tool. So running these in production after, if you have all your generations, that's pretty good. The way that we handle cost on our platform is that we basically we allow you to set a maximum limit, and then we just sample dynamically based on that limit every day. So if you want to run 30,000 evaluations a month, you know roughly what that's going to cost you, and you will just sample 1,000 a day from your inferences. So that's how we manage it. So it's it's up to you. It does add some cost, but the way that you can get around that is also, like I said, when you break it down into simpler techniques, you can use cheaper models. We've even tried using some fine-tuned models for this, for certain types of evaluations, but we don't recommend that for the most part. For anything with any reasonable degree of complexity, you're going to get much better results with something like GPT 3.5 or 4. Yeah, I was also going to say that another thing that sometimes we overlook this, but you can do this is you can use functions as evaluators which don't have to use an LLM. I basically skipped over this in the presentation because I feel like in some cases it's pretty obvious, right? Like you just want to use a regex matching or contains, check for if it contains a string or something. But I think you can even structure your prompts and your application in such a way that it makes it easier for you to use non-LLM based evaluators. So if you ask your main prompt, like one of the prompts in your chain, to give you a JSON object, and that JSON object needs to have certain fields, and those fields need to have certain values or things like that, it can open up some opportunities to do evaluation without using LLMs. Of course, you're not going to get any reasoning based type of stuff there, but but that's effectively free, right? You can run that on 100% of your responses. And then you can have some models which we're actually integrating some of these models in the next week or two, which are going to be like specifically geared towards things like detecting PII or detecting prompt injection attacks or things like that. And those can just be a lot cheaper then, right? Because their task it's so narrow and so focused, you can get away with a really small model. So then latency and cost isn't so much of an issue.
Yeah, I'm glad you brought that up because I'm curious about if you guys have used any like text embedding based approaches to doing this. Let's say like you, instead of like putting everything into the LLM, you generate embeddings for like, let's say the context and the response, and then you try to build like a text classifier or something like that, like query can match or response can be generated from context through just like a more traditional machine learning approach or deep learning approach.
Yeah, we haven't tried. Like I've thought about this idea, and like it is something that's been on my mind as like something I want to mess around with. We haven't really tried it because I don't know how well it would work for. So our use case, it needs to work for a broad spectrum of customers and use cases, right? Which makes it a little bit harder to do what you're talking about. If we were to build something like that specifically for one use case or customer or project, I think that would totally make a lot of sense and it would solve those problems.
Yeah, that's cool. All right. Any other questions, guys? Feel free to drop it in the chat or just go ahead and raise your hand.
I think there's a question which, if I'm understanding correctly, what the question is asking is that the LLM evaluation task is not related to the inferential capacities of the LLM. So let me just go back to this one slide. I don't know if I would say that it's not related to the inferential capacities. What I would say is that the fundamental task you're trying to perform is different, right? So we know that the same LLM can perform very well at some tasks and very poorly at some tasks. And typically what we've seen is the simpler the task, the better it's going to perform, right? Like that's, you can probably draw a pretty neat correlation between those two things. And so I always like to go back to this, which is that not everyone can draw a perfect circle, but everyone can look at a circle and look at a shape and say, this is a circle, right? So your evaluation task is effectively the latter. It's supposed to be pretty simple and straightforward, and you're just trying to identify if if the LLM is doing that one specific job correctly. And it's not always so simple of a task, but it can be. And there are some people have done some studies into like, there can be bias if you're using the same LLM for inference and evaluation. So if you use GPT 3.5 for inference and evaluation, there could be bias. You could, but theoretically, I believe that, from what I've seen just empirically, is that bias is minimal, and it mostly is mitigated by the fact that you're asking the LLM to do two different things, right? So any bias there is, it's like quite minimized by the fact that you're just doing two different tasks. And if you do want to minimize that, just use a different model, right? Like use Gemini for your evaluation or something. Hopefully that answers your question, but if it doesn't, please feel free to follow up.
So we got a couple more minutes. Any more questions? Ivorina said, thank you. That helps a lot. Yeah, go ahead, Santiago.
Hey, one more, Shiv. I'm curious if you could talk. This is more along the lines of the Athena product, but I'm curious, in what ways have you seen customers, or do you envision customers setting up these evaluators as part of their like CI/CD pipeline and check-in stuff? And I'm asking because we did a very quick and dirty one, which is basically a unit test, right? And so you run the unit test, it does like a simple eval, and then that lets you know if they failed, they passed, then it didn't get worse, or it performed well compared to like how they were before. But it's very rudimentary. So I'm just curious if you can comment on how you see that working well in a more robust environment.
Yeah, actually, we're putting out a blog post about this tomorrow, Santiago, so I'll be sure to send that to you. But it's honestly, it's pretty much, I think, what you've done. I would say the only difference is maybe you can run is what is the actual evaluation task, what is the data set, and maybe you can run it on a suite of evaluations rather than running a single one. And you could have multiple different steps that can pass or fail. Which is what we've done in ours. But fundamentally, what I've seen the best teams doing is some version of what you're talking about. That if you change the prompt, or you change what model you're using, you run the CI/CD, you run it on the same data set, so you run the inferences again with the new prompt or the new model or the new retrieval system, whatever it is, but your queries remain the same. And then you get a new set of responses, and you run your evaluations on those, and you check if the score is above your threshold, or if it decreases from the last known value. So it's probably pretty similar to what you've done, I think.
Cool. Awesome. Thank you.
Yeah, sure.
Thanks for the question, Santiago. If nothing else, we can go ahead and wrap up. I guess I'll give a beat if anyone wants to squeeze in any last questions. All right, well, let's thank Shiv again for a wonderful workshop. We will share the recording on the Data Entrepreneurs YouTube channel. If you signed up for the event through Luma, you should be getting a link after this call. And thank you guys all in the audience for joining. We will have another event next week in the Data Entrepreneurs Discord. It's going to be a huddle, so that's just an opportunity for people in the community to come together, network, share projects, share feedback with one another. So if that's something that is interesting to you, be sure to register for that on Luma. And with that, thanks again, Shiv. Thanks again, everyone in the audience, and we'll see you in the next one. Take care.